Hello guys, we are meeting once again. Our topic for today is diesel cycle or slow speed cycle. Now, the most important thing that you are going to be looking at, cycles are the most easiest and straightforward topics as long as you understand the relationship between your pressures, your volumes, as well as your temperature versus entropy graph. Once you survive on those two calculations and everything, it becomes quite easier. Now, our process here, it starts at this point where, which is the start of the compression stroke. The compression stroke, it ends at this point, but at point marked number V3 here, at this point, this is where our fuel cutoff takes place at the top, rather BDC, that's our bottom dead center. And then between points 2 and 3, you can see that our pressure P3 and the P2 are equal. This is where we have our fuel and air mixture or our intake. But between point 3 and point 4, we have our expansion stroke. Now, expansion stroke can be either polytropic or adiabatic, depending on the setup that we are dealing with. But between point 4 and point 1, we have our heat rejection. So look at our volumes. We have 3 volumes. We have V1 equals to V2, and then we have V2 as an independent volume. But another important thing that you must check, our V2 now becomes the same thing as our clearance volume. So we have 3 volumes, which is the first volume CV equals to V2, and we have V3 as well as our V1 equals to our V4. These are easy marks for you to get in the exam as long as you understand how to interpret this graph. Now let's go to this question. The question says a single cylinder operating on the diesel cycle, yes, a piston rather has a clearance volume of 410 centimeter cubed. Piston diameter is 176 millimeters. The stroke length 254 millimeters. Fuel cutoff a 10% off. A swept volume at the top, a dead center. P4 is given as 337.8. T4 is given as 995. Our gas constant is given as 0.288. Expansion and compression follows the law PV to the exponent of 1.35 equals to C. Calculate the volumes, pressures, and the temperatures at all the main points in the cycle. And then number B, we need to calculate the work done. So the first step which you need to look at, we are supposed to look for the volumes. So let us start off by getting our swept volume. But swept volume equals to pi d squared over 4 times our L. So here they didn't emphasize whether we should leave our volumes in what, so we can leave our volumes in cubic meters. So let's go together. It's pi times, we have 176. If we divide by 1,000, changing to meters. So we have 0.176 squared over 4 times our stroke length, which is 254, which is 0.254. So let's get our swept volume. Shift pi times 0.176 squared over 4 times 0.254. I'm getting my answer is 6.179 times 10 raised power of negative 3 centimeter cubed, rather meter cubed. So we have our swept volume. So once we have our swept volume, the second part, remember already we're given our clearance volume as 410 centimeter cubed. So we need to change, we can change it as we are calculating it. Now we have our swept volume. Now let's get our V1. But V1 equals to swept volume plus our clearance volume. The same formulas that we were using on our Otto cycle. So we have 6.179 times 10 raised power of negative 3 plus 410, it's centimeter cubed, so we multiply by 10 raised power of negative 6, changing centimeter cubed to meter cubed. So we have 6.179 times 10 raised power of negative 3 plus 410 times 10 raised power of negative 6. So I'm getting 6.589 times 10 raised power of negative 3 cubic meters. So we have our V1, we have our SV. So what else do we need? Because we said V2 equals to our clearance volume, which is given as 410 times 10 raised power of negative 6 cubic meters. So we have swept volume, we have our V1, we have our V2. So what we need to get is to get our V3. Now to get our V3, in this case, there was an emphasis where they said fuel cut off at 10% of swept volume after TDC. So V3, therefore, we are demonstrating what they are saying, 10%, 10 over 100 times, they say swept volume. So that's what we are trying to do. So it's 10 over 100 times our swept volume plus our clearance volume. That's how we calculate our V3 in a scenario like this one. So we say 10 over 100 swept volume, we said it's 6.179 times 10 raised power of negative 3 plus our clearance volume, we said it's 410 times 10 raised power of negative 6. So let's see what are we getting as our V3. So it's 10 divided by 100 times 6.179 times 10 raised power of negative 3 plus 410 times 10 raised power of negative 6. So I'm getting my answer as cross check something. We have 6.1 79 times 10 to the power of negative 4 plus 410 times 10 to the power of negative 6. So plus 410 times 10 raised power of negative 6. So I'm getting 1.029 rather 279 times 10 raised power of negative 3 cubic meters. So that becomes our volume, or you can round off to 1.028 times 10 to the power of negative 3 cubic meters. So we have all our volumes in the cycle. So we are done with the volumes. Now the second part that we need to look at, they want also us to calculate the pressures. So let's look for our pressures. What are we given so far? Is there any pressure which we are given? We are given our P4 and then we are also given our T4. So since we are given our P4, we can get our P3. So we can use our formula P3 V3 to the exponent of n equals to P4 V4 to the exponent of n. So we can use this one. Therefore, P3 equals to P4 bracket V4 over V3 to the exponent of n. So our P4, it was given as 337.8. Our V4, because in this case we are not given the compression or, so we have to use the values which we calculated. So our V4, we got our V4, don't forget here, V4 is equal to V1. Remember, V1 equals to V4. So where we wrote our V4, we can also write V1 because the volumes are constant. So our V4, we got 6.589 times 10 to the power of -3 divided by our V3. Our V3, 1.028 times 10 raised to the power of -3. Our n, it was given to be 1.35. It's to the exponent of 1.35. Let's see what are we getting. 337.8 times bracket 6.58, 9 times 10 raised to the power of -3 divided by 1.028 times 10 raised to the power of -3 to the exponent of 1.35. So I'm getting my P3 is 4148.35 kilopascal. So we have our P3 and then we have our P4. So don't forget, if you look at our PV graph, we have a straight line here which demonstrates that P2 and the P3 are the same. Therefore, P3 is equal to P2, which is 4148.35 kilopascal. So which pressure is now missing? We have P1, which is missing because we have P2. So we use our formula P1 V1 to the exponent of n equals to P2 V2 to the exponent of n. So we can now use this formula to get our P1. Therefore, P1 equals to P2 into V2 over our V1 to the exponent of our n. So let's get our P1. P2 is 4148.35, and then our V2, we said V2 is the same thing as our clearance volume, which is 410 times 10 raised to the power of -6 over our V1 is the same as our V4, so it's divided by 6.589 times 10 raised to the power of -3 to the exponent of 1.35. So let's get our P1, 4148.35 times bracket 410 times 10 raised to the power of -6 divided by 6.589 times 10 raised to the power of -3 to the exponent of 1.35. See what are we getting? I'm getting 97.662 kilopascal. So we have all the temperature, rather the pressures and the volumes at all the cardinal points. What is now left is for us to get the temperatures. But already we have our T4. So we are going to look for T1, T2, and T3. So the easier one that you can start off with, because we have T4, we can now use T3. I think we can calculate, allow me to calculate temperatures from this side. So we can say T3 divided by T4 equals to V4 divided by V3 to the exponent of n minus 1. So we're looking for T3, therefore T3 equals to T4 into V4 over our V3 to the exponent of n minus 1. What's our T4? T4 is given as 995 Kelvin. Our V4, it's 6.589 times 10 raised to the negative 3 divided by our V3, 1.028 times 10 raised to the negative 3. Our n, it's 1.35 minus 1, it becomes 0.35. So let's see what are we getting there. Let's see what are we getting. We have 995 times bracket 6.589 times 10 raised to the negative 3 divided by 1.028 times 10 raised to the negative 3 to the exponent of 0.35. I'm getting 1906. So I'm getting 1906.39 Kelvin. So we have our T3, we have our T4. What is missing? T2 and our T1. So we can use a simple formula. P1 V1 equals to P1 V1 over T1 equals to P3 V3 over our T3. We can use this one so that from there we can get our T1, because we have everything with the exception of what? T1. So T1 equals to P1 V1 T3 over P3 times V3. Let's see what are we having. P1, we got it as 97.662. Our V1, 6.589 times 10 raised to the negative 3. T3, 1906.39, all divided by P3. P3, we said it's 4148.35 times V3, which is 1.028 times 10 raised to the negative 3. Let's see what are we getting as our T1. 97.662 times 6.589 times 10 raised to the negative 3 times 1906.39 divided by 4148.35 times 1.028 times 10 raised to the negative 3. I'm getting 287.6 7 Kelvin. So we have everything. What is now missing? It's our T2. So we can now say but P1 V1 over our T1 equals to P2 V2 over our T2. So we are on track on this. What is missing? There's our T2. So T2 equals to T1 times P2 times V2 over P1 times V1. T1, we said it's 287.7 times P2, which is 4148.35 times V2. V2, we said it's our clearance volume, which is 410 times 10 to the power of negative 6, all over P1, which is 97.662 times V1, which is 6.589 times 10 raised to the power of negative 3. Let's get our T2. 287.7 times 4148.35 times 410 times 10 raised to the power of negative 6 divided by 97.662 times 6.589 times 10 raised to the power of negative 3. I'm getting 760.421 Kelvin. So that becomes our T2. So we have all our volumes, we have all our pressures, we have all our temperatures across the 4 cardinal points of the cycle. Now number D, they want us to calculate our work done. So they want us to calculate the work done. So work done, which you can use the work done in kilojoules per cycle, so which is number B. So work done, we can use our formula MRT, because yes, we can use that one. We can use MR into T3 minus T4. We divide by our N minus 1. Do we have our mass? Are we given our mass? So our mass is not given, therefore we have to look for our mass. How do we calculate our mass? Because we have everything, so we can use our formula P1 V1 equals to MRT1. So from this formula we can get our mass. So M equals to P1 V1 over RT1. So let's see what we have. Our P1, we said is 97.662 times V1 at 6.589 times 10 raised to the power of negative 3. Our gas constant 0.288. And then our T1 we said is 287.7. So let's get our mass. Let's get our mass for that one, which becomes 97.662 times 6.589 times 10 raised to the power of negative 3 divided by 0.288 times 287.7. I'm getting 7.766 times 10 raised to the power of negative 3 kg. So we now have our mass. We can come and substitute here, which is 7.766 times 10 to the power of negative 3. Our gas constant 0.288 into T3. Our T3 is 1906.39. T4, our T4, it was given as 995 over our n, which is 1.35 minus 1. So let's get our work done. 7.766 times 10 raised power of negative 3 times 0.288 into 1906.39 minus 995 divided by 1.35 minus 1. I'm getting 5.82 kilojoules per cycle. Yeah, so that's how a question of this nature is to be addressed. So the most important thing that you must remember here is to understand your pressure versus volume graph. And also you can also check on the temperature versus entropy graph. Once you remember that, it's very easy for you to survive when you have a question to deal with the diesel cycle or the slow speed cycle. Remember, we have how many? Maybe we can summarize here. Remember, on a diesel cycle, we have the following. We have 3 volumes. V1, which is equal to V4. And then we have our V3, which occurs on the part of the cut-off. And then we have V2, which is also our clearance volume. We are done. So we are done. Another thing which is important on a diesel cycle, if you are given a compression ratio on a question like this, let's assume the compression ratio was given as 8:1. Remember, this ratio is V1:V2. So which is to say, this ratio only applies when you have got V1 and V2. You cannot use it on V3 because V3 is outside the given compression ratio. Let's meet once again as we are going to be doing the Joule cycle. Sharp.